Okay, great. Everything look good? Yep, cool. So we'll keep this again because it's kind of the small group in here. We'll keep it relatively informal. So feel free to stop and ask questions kind of in the middle as we go. Do a little bit of a Kaleido introduction, just to kind of ground you in who Kaleido is in the ecosystem, how we're involved with these projects with the Linux Foundation, talk about FireFly, as well as then get into a demonstration kind of around the Kaleido platform and the way that FireFly itself kind of powers kind of interaction with stablecoins. Just by brief way of introductions, you got two of us up here, Andrew Richardson, principal engineer from Kaleido, and myself, Trevor Scandlin, technical enablement. We're both based in Raleigh, so at our headquarters there. Yeah. So Kaleido, we were founded with the intent to make blockchain and digital assets radically simple for enterprises. So our four founders all came from IBM, where they were part of the original team who helped build the IBM managed blockchain platform, create the Fabric code base, help set up the Hyperledger Foundation as a part of the Linux Foundation. So we've been very kind of tied over time to always really investing in best of breed open source technology that our enterprise clients want to use. So that's looked like over time kind of support for a variety of open source chain infrastructure protocols. Specifically, the one to call out at this point is that Besu has a really special place in our hearts. We are Besu maintainers and drive the enterprise roadmap for Besu, but as well as then moving up the stack, FireFly as kind of a piece of middleware that we recognized early on in our company's kind of timeline, that we were doing these projects and we were building the same thing in the middle over and over. And it is the thing that we saw different consultants and different projects also rebuilding every time, but they were spending tens of millions of dollars and projects were failing because they created this really complex custom piece of middleware that we say, hey, we've now built this half a dozen times and there are kind of some patterns that are coming out of what needs to happen. So let's go ahead and take that kind of what Kaleido has created, our special sauce at the time, and open source it. And that's what became FireFly over time. So again, FireFly is really kind of a growing and evolving code base based on kind of our learnings, implementing real solutions for our customers. You can see here, again, a little bit more of kind of an overview of Kaleido. Very involved in a lot of research in the space around deep technology, specifically totally separate to this conversation, but some really cool research going on around zero knowledge proof-based tokens, quantum resistant and performant kind of ZKP tokens for kind of new privacy technology, which Andrew probably won't touch on the math behind all of that later, but Paladin in the workshop in a couple hours, we'll touch more on kind of privacy technology for EVM, open standards, very involved, like you said, with open source, and again, specifically with the Linux Foundation, Decentralized Trust, very engaged with that group, sitting on both the governing board, technical advisory committee, very involved with a number of the open source projects there. So this is probably the last kind of very Kaleido-y slide that you'll see from us today. This is again just meant as an overview of kind of the landscape of what it is that Kaleido does. So you can see here that kind of the Kaleido platform, we have digital assets, Web3 middleware, and chain infrastructure. Web3 middleware is where we'll really focus today, focusing on FireFly. Involved in a number of open source communities. We run chain infrastructure and kind of support ecosystems and protocols across the board. So again, this is not the whole list. And part of what we'll talk about today is that over time that we add support for more and more communities over time through stuff like the Cardano connector that was recently developed and donated to the open source FireFly project, which is a real enabler now for the Cardano ecosystem to be able to use FireFly as a middleware tool, as kind of a platform, or as a set of standard ways and APIs that they can use to interact with Cardano and to build applications against a whole bunch of other networks, whether it's a Hedera hashgraph-based network, whether it's a R3 Corda, Canton, or various Ethereum networks, whether they be public or private. So here, kind of, I want to show this this slide just to kind of show, at least when we're talking to customers, this is kind of the big. This is, I wouldn't say a 30,000-foot view. It's more like a 5,000-foot view of kind of the architecture that ends up kind of being behind a lot of these enterprise applications. You can see that, again, we have chain infrastructure that is always necessary. A lot of our customers, they want to bring their own smart contracts. They have a lot of their IP is the smart contracts and how they operate, the assets that they're trying to tokenize and what those assets do. But those assets need to not just live on a single chain. They need to be flexible and able to live on multiple different chains over time. Here in the middleware layer, which is where we're really going to focus on in just a second, you have Web3 middleware, and we'll kind of double click into this box. But again, a lot of capability that's necessary in the middleware, whether it is flexible APIs for invoking smart contracts, reliable event listeners for indexing transactions on chain, subscriptions to get that information from the chain back to your application, as well as then creating your own interoperability bridges and integrations, whether it's to core systems or anything else. You have kind of a digital assets and tokenization layer, which is where, hey, I need to model my assets. It's not just a smart contract on chain. It is, what is that smart contract and what does that mean to my business? I'll show you later that I've got the USDC smart contracts deployed onto a private network, and I've deployed my own instances of those contracts onto Sepolia. But functionally, those don't mean anything because it's just a smart contract. It's then about what is the business behind it? What is Circle has built? A huge business based on accepting fiat and minting stablecoins, and then showing people that they can trust that, hey, when you want to come redeem this, we have the cash behind it that you can get it back into your system. Now, again, as blockchain developers, as we kind of push stablecoin payments around, people start to kind of get more comfortable that, yes, this thing is currency, that kind of on-off ramp might not be as important, but somebody still needs to hold the actual value behind it. So this digital assets and tokenization layer is really all about saying, hey, I've got information on-chain that I care about, but I need to marry that with kind of the off-chain, the business context behind it, because without the two of them together, it's just another smart contract, which is really important, and something that we're really going to focus on here is around enabling integration with those smart contracts. But again, for the kind of overall applications that we build, there's a lot more that needs to go on to do this. Carry on. So you can see here kind of FireFly, where we're really getting into today, is really kind of the beating heartbeat of this Web3 middleware. And we'll kind of double click into this box in just a second. But FireFly itself has a lot of capabilities around API gateways to submit transactions, event streams, off-chain data correlators. And so that means it's able to take data from external systems and upload that data and save that data that you can then reference in conjunction with on-chain transactions. There is Oracle-like capabilities with FireFly. And Oracle fundamentally is helping you bring off-chain data and associate it with something on-chain. Now, sometimes that might look like, hey, I need to get a foreign exchange rate. I need to get the current price of an equity or something because somebody is trying to buy some asset from me, and I need to get the price right now of what that is in order to set up the trade. Otherwise, there's inefficiencies in the market. FireFly can help with those types of things. Getting into FireFly, FireFly is a very modular framework. So kind of what I mentioned at the beginning is that, again, FireFly has grown out of our learnings working with enterprise customers for nearly 10 years at this point. What we learned very quickly is that they need standards, but they also need to be able to plug into their very custom things. So they need to be able to plug into their own identity management systems, their own backends, their own data storage systems, their own key management systems. So FireFly was created with the architecture in mind that, hey, this needs to be modular. It needs to be pluggable. And that's actually come in really, really handy then when it starts to look at, hey, FireFly was initially created and has really good support for EVM chains. But then over time, all it takes to enable FireFly to talk to other chains is somebody to build a connector, essentially teach FireFly how to talk to a specific chain ecosystem. I'll talk about that a little bit more later, but that's actually what group Sunday Labs, who has a booth in there, did very recently. They built a Cardano FireFly connector. So it's teaching FireFly how to use kind of the core components of FireFly, the APIs that it gives you, FireFly Core, the transaction processing engine, but then translate that into a Cardano on-chain transaction. Again, it's all a translation layer. So there's an EVM connector, there's a Cardano connector, there's a Tezos connector that the community also built and donated. And again, that was done totally outside of Kaleido. And that's why for us, kind of, it's so important that we push so much of what we do into the open source, because we want other people to look at it and to pick it up and to find value in it. And so luckily, FireFly is probably one of the best examples of that we've seen when it comes to people really picking it up, really being like, wow, this is valuable, but I wish it could talk to this network. I'm going to go build that for myself, and so I can use it. Pause here. Andrew, anything that you would want to call out or highlight so far? No?
No, I think we should run some transactions there.
Cool. So again, just getting kind of another layer deeper into, again, FireFly and kind of the pluggable nature of it. You can see down here, especially when it comes to kind of that blockchain connector implementations, that there are all these public blockchains. And again, it now can support Cardano because of that connector that it actually, that Sunday Labs wrote and developed and donated to the open source community. Give that just a minute. Cool. Again, here, talking a little bit more just about that Cardano connector that is all pushed into the open source. If you go look in the Hyperledger Foundation, you can find their GitHub repository for the connector specifically under FireFly Cardano. This is just a screenshot of kind of showing kind of the architecture and the way that you can see that it goes from FireFly core. They do translation to make it specific to Cardano and the way that Cardano in the chain works, integrates with the FireFly Cardano signer for signing transactions. Specifically, then also if you keep your private keys in your own system, it can integrate with that really seamlessly, and it integrates with BlockFrost APIs and Cardano nodes and everything like that. So anyway, if you don't follow them already, I would recommend kind of following Sunday Swap. That is the Twitter handle just of Sunday Labs. They seem, I'm not the most familiar with them, but the more that I look, they're doing some pretty cool stuff. I was just talking with them earlier this week about kind of some permission pools stuff that they're looking at doing, which seems very interesting and something that I would like to look at more because the types of clients and people that we talk to are interested in doing that as well. So we'll get over here now and actually out of slides and into kind of actual kind of looking at FireFly and looking at what it does. So I'm going to do this though through the lens of the Kaleido platform. So again, one of the things I talked about is that Kaleido FireFly is an open source project. We run an enterprise version of FireFly, which really means we take the open source code. We have some specific kind of easy connectors that we've built into our platform, but we fundamentally, the functionality that we run in FireFly and that we're going to talk about and show here is all available in the open source. It is actually a good thing to point out as well. If I come over to the docs here, you can see hyperledger.github.io/FireFly. There's a great getting started page where you can download FireFly locally, run it on a Docker container, start it up entirely through the CLI. I was talking with, just as I was walking up here, Bob Blessing-Hartley, CTO Shielded, and he was saying that just a couple weeks ago, he was messing around with the CLI to stand up specifically a FireFly node with the Cardano connector so that it could talk to Cardano. So it's a really useful tool for getting started, for experimenting with it. And I should always point out that that you can interact with the community here. There's a GitHub, sorry, not GitHub. There's Discord for the Linux Foundation. There's FireFly channels within there where the maintainers are. If you're ever trying to use this, if you're running into problems, if you see bugs, you can go to the Discord, ask there, and maintainers are always in there and very happy to help. And if we don't respond, then Rai will poke us and say, hey, take a look.
Yeah, just jumping in on and plugging the open source community around FireFly, it has been a really great community. I'm one of the maintainers of FireFly, so kind of wrote a lot of the original code and try to stay involved in how it's shaping up. But like these docs he was showing on the getting started, especially if you're someone that's got an idea for a blockchain project, I want to learn a token, or I want to start playing around with smart contracts and get into this ecosystem. It's a really, really easy way to connect to any chain, because part of onboarding these connectors, starting with the Besu connector, and then these other ones, Cardano and Fabric and whatever else has been onboarded. They all can support just kind of out of the box couple steps. I can either stand up a local blockchain and talk to it like a private one on my laptop, or I can connect through something like Blockfrost. It gives you a lot of options for just bootstrapping your own blockchain project on a private chain, and starting to play around with it within minutes, right? It gives you a full development environment. So definitely find the docs, find Linux Foundation. It's very easy to find FireFly on GitHub and through Linux Foundation /Hyperledger, and connect with us.
Cool. Cool. So we will, excuse me, we'll get into the demo part now. So a couple things to point out. So what I have set up in here is an environment of, again, through the lens of Kaleido, but we're going to primarily focus on the middleware, and kind of I'm going to point to a couple different parts where it's kind of showing that, hey, I took smart contracts here, and maybe I'll start here. So what I have here is the token smart contracts from Circle that they use for their USDC token. Those are open source contracts, so I was able to take those, upload those to the platform, and say, hey, go ahead and give me kind of builds of these contracts. Builds are fundamentally just the ABI and the bytecode of these smart contracts. So fundamentally, the USDC smart contracts have a master minter token. They also have a proxy and an implementation. They follow an upgradable pattern. The master minter controls who's able to mint. That's where kind of you say, hey, this address has a minting allowance of this amount. That is a safeguard that they put in place. But again, these are fundamentally the same smart contracts that Circle uses for USDC. And so when I eventually start running transactions and you see me, hey, minting tokens or transferring tokens with APIs from FireFly, that is the same way that you could also do that for transactions on public networks. On public networks, actually move USDC with the APIs of FireFly to do that. So again, I have kind of network set up here where I have a private Besu network. I have Sepolia here as well. FireFly connected to each of those. And just to get into it then, if I come into here, we can see that this is very similar to kind of a dashboard that you might see through FireFly. We come into here to APIs. Once I uploaded smart contracts, I can then teach FireFly and say, hey, go ahead and create me APIs for these smart contracts themselves. And now I can use these APIs to actually interact with the smart contracts on chain. You don't need, there is a FireFly SDK. You can use just these APIs here. Let's see, the one I want to open up is right here. And you can see once I've taught FireFly about the smart contract interface, it then generates for me an API surface that I can use that has all of the methods of the smart contract. And again, it's generated that from the ABI of the smart contract. It gives you invoke endpoints, which is really results in a ETH send raw transaction on chain. It also gives you listener endpoints, which is your way to tell FireFly, hey, go ahead and start listening, start indexing these specific emitted events from the chain. So you can see that each one of these, if we were to look into the ABI of the smart contracts, these would all have events that are emitted from them. So anytime somebody blacklists a certain wallet address or burns certain tokens, there's an event emitted on chain. You can tell FireFly, hey, I don't care about any of the other events that are happening on this chain. I do care about this specific smart contract, and I care about this specific event, excuse me, from that smart contract. Listen to every single transaction and filter out everything that is not these specific events. And so in that way, especially on a public chain, there might be millions of things going on that you don't care about, that your application doesn't care about. You need a system that reliably listens for the events that you do care about and picks those up. FireFly can do a lot of that for you. And then finally, it also gives you query endpoints. And so this is just if you need to query the state of the chain, if you need to query kind of something that's going on, we should be able to query somewhere total supply. There, great. So if I want to query, hey, what's my total supply of the kind of tokens minted on chain right now, we can do that through FireFly, and it'll very, very quickly say, great, here's your output, here's your total supply of the tokens that are on chain. So again, this is the API surface that FireFly will generate for you that you can then use to interact with the smart contracts on chain. So if I were to come in here now and actually go ahead and say, hey, I want to go ahead and transfer some tokens. I'll come right here. You can see I have this invoke/transfer. I believe I'm going to be doing this on the Besu network. So let me just grab that earlier so I'm not fumbling around as I'm trying to do this live. You can see actually it is important to call out here. You can see here that it gives you kind of a formatted body of the request based on, again, the expected inputs of the smart contract method. So it's taking away a lot of the complexity. You know exactly what it is that you need to pass in. This Swagger page is giving you kind of those values. It is generating that from the smart contract interface. It also gives you the ability to pass in your own item potency key, which is really important, especially for our enterprise clients who say, hey, I need to know exactly the state of every single transaction that I submit. I can't be just missing one. An item potency key gives you a way to track that transaction, to retry that transaction if something were to go wrong, and record that in your database. So if I were to click execute right now, what I'm fundamentally doing is I'm moving some of these USDC tokens from my wallet address right here, which I should have probably shown you guys previously through an API call, has a balance of this token right now, and I'm sending it to this other address. You can see that I invoked that. I got a 200 response back. And so now if we come back over to the platform, we can see that just a minute ago that we actually had a contract invocation. This is, again, very similar to what you would see through if you're running FireFly yourself. It does have a really nice UI that gives you a way to kind of visualize the status of transactions. If I come back over to the docs, I believe that there's actually a screenshot, yep, right here. So this is, again, a UI that through the open source, you will have yourself as well to visualize some of this information that we're seeing through the Kaleido platform as well. It has a section that shows you what APIs have you taught the platform, everything like that. But we can see here that, great, with just an API call, we can see that we have success. If I want to click into and look at more information about this transaction, I can do so specifically here. This is what I care about, transaction success. If I want to check the inputs and what happened, I sent value to this wallet address. This is how much I sent. And here's some other supporting information that FireFly gave me about what happened. That's, again, getting transaction information onto the chain, invoking a smart contract on chain, making something happen on chain. FireFly handled for me, if I come into the transaction manager, this FireFly transaction manager is, again, another piece of open source. It is out there in the open source. And what it did for me is it handled nonce assignment, it handled transaction signing, submitting the transaction, getting the receipt of the transaction. So it handled the full transaction lifecycle instead of you having to write kind of something more custom using a library or something like that. With just an API call, FireFly took care of saying, okay, great, what's the next nonce in my sequence? Let me go sign that with kind of the signer that I have configured. In this case, a very simple HD wallet through the platform, but if you have your own signing capability mechanism, if you use a custody provider, if you use an HSM, you can do that. It tracks the receipt. So it's looking for, hey, did this transaction end up in a block on my chain? And then confirming that transaction. So that's, again, everything that FireFly is doing to help you get transactions and state changes onto the chain. The second part of FireFly that's really important is basically, cool, what does FireFly do to help me listen to what's going on chain, get information back off of the chain itself? It does that through two primary components. We have listeners, which I'll touch on and talk about a little bit more, but it's fundamentally what I talked about before, where you have a listener, you can tell it, hey, here's a contract that I care about and an event that I care a lot about. Please go ahead and start listening to all of those, as well as down here, subscriptions, which we'll touch on in a second. So listeners, like I mentioned, are essentially your way of telling FireFly, hey, out of the world of everything that's going on this public chain. Right now, I did this transaction right here on Besu, but I can actually, let me switch over and I'm going to go ahead and start a transaction on Sepolia. And we can kind of then throughout this go to the public explorer and then see that transaction come up. If we go to invoke transfer, again, right here, again, same API endpoint that we did before. Let me grab that request body that I pre-did. Execute, great. So this one's going to take a few more minutes, or going to take a little bit longer. The reason for that is because on a public network, the one that we did previously was on a private network. Finality on a private network is instant. As soon as the block is mined, it is final. On a public network, that's not the case. There might be forks, there might be rollbacks, something like that. So you have to set up kind of FireFly has intelligent tracking of transactions. So it's looking for basically, hey, great, here's my transaction. I'm going to keep it in pending until the configured number of confirmations comes through. Really, confirmations means how many blocks have passed where this transaction is still in the chain of blocks, and how many blocks need to pass before I consider that, hey, the economic, the amount of money or compute power that somebody would need to rewrite these last 6 blocks is so great that basically that it would be unfeasible and would be economically unviable. You can tell FireFly configurable numbers of confirmations to set. So on Ethereum or something like Polygon, you might want like 6 block confirmations. On other networks, maybe more, maybe less.
Well, the big thing to highlight here is the purpose of FireFly on this middleware layer, and the way we see the need for this particular piece is that it decouples those decisions about how the blockchain functions from how I use the blockchain, right? I can write, you see the way Trevor did a transfer, you know, if I'm deploying my stablecoin contract, I'm deploying it on 3 different chains and they have 3 different characteristics in terms of, you know, do I have to wait for a certain number of blocks for confirmation? Do I have to assign nonces and spend gas in a particular way? It decouples those 2 decisions, and you're able to kind of make your business logic decisions at one layer, and then make your chain sort of specific semantics at another layer, and the translation is seamless there.
Cool. So again, we can see that we even submitted that transaction onto Sepolia. We see that we got 4 confirmations. Let's see if we go over here, go to Etherscan, look for that transaction. Great, 1 minute ago, we can see that we sent a small amount of tokens from one address to another address. And FireFly FireFly took care of, kind of, as Andrew was saying, kind of all the characteristics of what is it of getting that transaction onto the chain itself, abstracting away a lot of that. Hey, what does it mean for me to consider this transaction to be final? In this case, I've configured it to say, hey, this transaction needs to be in 4 blocks before I consider it to be final. So again, a lot of fundamentally, again, that was just kind of how do we get transactions and information onto the blockchain. Now, the second part of what we care about is, again, then cool, once we've gotten something on, how do we listen? And how do we kind of tell the platform, tell FireFly, hey, there's specific events that I care about that I want to get off of the chain. So we have here, FireFly has a capability called listeners, which uses the same smart contracts that we've uploaded in FireFly language. Those are called FireFly interfaces. You create a FireFly interface, which is essentially you teaching FireFly that, hey, there's a smart contract. There's kind of what am I looking for? Here's the way that the smart contract operates. Here's the functions of the smart contract. Here's how you talk to the smart contract itself. It's called FireFly interface.
Well, yeah, and FireFly interface is designed as a language abstraction because for Ethereum, it's API. Anyone that's read like API defines what are all the inputs, what, you know, how's your contract structured. But other chains potentially have different ways of describing. So the FireFly interface is just a generalized way to describe what are the inputs and outputs of my contract, and how do I call those.
And then here, I've defined for FireFly that I've said, hey, there's this smart contract address right here, and there's this event that is going to be emitted on that smart contract address. These are all of the events that I care about from this smart contract. So FireFly, please go ahead and start listening to all the transactions that come through that you're listening to on the public, on the private chain, whatever it is. Filter out anything that doesn't match kind of what I've set up here. And if you find something that does match, go ahead and record it for me. So you can see here that FireFly has gone ahead and this is, again, my FireFly that is pointing at Sepolia. So there's a lot more going on the public network than just the transactions that I care about. But I've told FireFly, go ahead and get rid of everything else that I don't care about. Yes, listen to it, filter through it, but only keep the things that I've told you that I care about. So FireFly is giving you really reliable ways to listen to events. This is actually, we were talking with, again, another team from the Cardano ecosystem yesterday, who was telling us that, hey, we've got a gaming gaming use case in a gaming project. And specifically, we were looking at kind of better ways that, hey, how do we index a whole bunch of data? How do we get a whole bunch of stuff from the chain itself? Because our application can't run just always every time we need to get some information querying the chain itself. We need to build this off-chain data source, and we need a reliable way to get that data from the chain to my database so that then I can build my application against that database, but still know that it's reliably referencing on-chain information. So they took a look and used kind of that new connector that's put out and are starting to look at kind of integrating that connector with FireFly into their system so that they can reliably index information from the public chain, from Cardano, that then they can use to build their application. But again, they've done so in a way where they now don't have to kind of filter through all the junk that they don't care about, all the other transactions that they don't care about. They can tell FireFly, hey, these are the transactions I care about. These are the ones that are important to my ecosystem. And then what they also use here is a thing called subscriptions. And this is how then they get events from FireFly once it has indexed them and say, great, I want you to send a record of that event to my own system. If I actually change my screen share for the benefit of the recording, we can see over here that what I've got here is a very simple example of one of those subscriptions. So I've set up a subscription and I've told FireFly that I want to listen, sorry, trying to talk and type at the same time. I want to go ahead and set up a WebSocket subscription where I'm telling FireFly now, go ahead and send me any events that you've received that you're holding on to that you need to tell me about. This is the way to get information out of FireFly back to your core system. And so in this way, I've set up a WebSocket connection to my FireFly node. I've now told it, go ahead and start sending me any events that are held on this subscription name, this invoke ops succeeded. If we look over on Besu, we will see this subscription right here. That's all right. We will see this subscription right here. This is the name of it right here. So we've told it, start sending me any events that are being held by this subscription right now. What's happening in the background is that, again, we're indexing these events and we're then telling it that, hey, FireFly, I want you to go ahead and store all those events, and I'm going to ask you at some point to send me a record of those events. And each time you send me an event, I'm going to acknowledge that event saying, yes, I got it. And so that way, if there's ever interruption in your connection, or if you're ever unsure of like, did I actually get all the events? FireFly has sequenced and has stored all of those events. You can always go back and tell it, hey, start from the last event that I had, or from the first event that I haven't acknowledged, or go ahead and start from a sequence number, kind of, maybe it's, I've got 1 through 200, but I'm missing 201, and then I have 200 through 205. Can you go back and start at number 200 again and send me everything from there, because I want to make sure that I'm not missing something in the middle there. Subscriptions are fundamentally your way to define that, hey, I want to go ahead and get that information from FireFly. This is it sending me a record of, cool, here's an event that you probably care about. This was one of those transfers that we did earlier. You can see the same input information right here. And so now I go ahead and I acknowledge this. I just take an acknowledgement. I pass in the ID of the transaction. This is, again, my application telling FireFly, thanks, I got this one. Go ahead and send me the next one. I acknowledge it, and it immediately goes, great. Now that you've acknowledged it, here's the next event. And so it's going to ask me to just keep acknowledging these. If we actually see right now, if I were to disconnect right now, we see that the last event that I have not acknowledged yet is this C6C event. If I go ahead and disconnect, connect back again, I'm going to have to go ahead and tell it, hey, go ahead and start sending me events from that subscription again. It says, sure, will do. And it says, great, you haven't acknowledged this C6C event yet. So it sent me that again. It's still waiting for me to acknowledge it. Again, if I disconnect, it's going to do this as many times as I ask it to until I acknowledge it, at which point it'll then say, great, now that you've acknowledged this event, I can go ahead and I can start moving on to the next ones.
Yeah, and just calling out here, two of the things that this is giving you, I think, are some of the things that can be overlooked when you're starting a blockchain kind of project, is that blockchains are actually pretty bad at being your source of queryable information, right? They're very good at providing a record of that information, but if you want to go back and query them for the current state of something, it's actually not very efficient. So it tends to be more efficient to have an off-chain data store where you're replicating things as they happen on the blockchain, just the things that you care about, and then you can cross-reference them. So that's part of what FireFly is providing here, is that you tell it the things you care about as they happen on the chain. It replicates them to an off-chain data store, a Postgres database that's very, very efficient to query and filter in large volumes. And then you can always correlate that back with the chain. Yeah. The connector here helps. And so we're talking about different pieces here in terms of if you are building an application, if you're building, a marketplace or a gaming app or something, and you're building something that's going to interact with a contract on chain. FireFly can be something that you include in your stack so that, when you need to query the current state of things, you can query FireFly first rather than going straight to the chain every time. But the connector is providing the in-between, depending on what the chain is underneath. The connector is providing both directions, right? It's providing that transaction workflow for how do I get something on the chain, and then it's providing whatever this chain is, what are the interfaces that it gives for listening? If it's Ethereum, I'm setting filters, but whatever the underlying chain is, how do I get stuff off and translated? And we have FireFly providing sort of a standard format for what does a transaction look like going in, and what does an event look like coming out? Because those are very common concepts and how blockchains work. They're very event-driven systems, right? I propose something that I'd like to be true, and then I wait a while, and eventually it probably becomes true. Tell me when it's true, and then I can act on it, right? And so it's just implementing that pattern universally across whatever chain tech it is.
Did I see you had a question?
I did have a question on this time, but
That's all right.
yeah. So what I'm kind of understanding here is this is almost like, so comparing to like, the public chain explorers, right? Like that's more of like a repository of information, right? Like you can't really query it very well. It might not be very specific to your needs, right? So this is kind of like for your application specifically, like, so this tracks transactions coming in and out of your application. And it can also kind of help to standardize multi-chain interaction. Am I understanding that correctly?
Yeah, definitely. And so it's your tool. If you're building something, you're building an ecosystem, you're building an app, for you to build, you could build an interface on top of this, right? We're showing just kind of the raw FireFly, what's there, but you can imagine it's very easy to then take that and build your front end, or whatever. If you want to build an explorer for sort of your interface, or if you're building something more complex, then you can build it on top of FireFly, and it gives you that in-between layer. And then if you add another chain or you change your chain, that upper interface doesn't change, right? That's the huge thing, is that you're not coupled all the way through your stack. There's this sort of generalized middleware, and you build on top of that, and then you can kind of swap pieces out underneath.
Thank you.
Yeah.
Cool. So I'm truthfully kind of reaching the end of what it was that I had planned to show. At this point, I wanted to leave we've got about 15 minutes left, I think, before the next group kicks off, or at least before the end.
At 15 after, that's the planned end of this.
Okay.
There's nothing except lunch for an hour. And then the next meeting is in this room at 1:15.
Perfect.
So if you want to sit here and continue to chat, that's fine.
Yep.
I'm going to go get lunch.
That's fine.
Yeah. Want to plug too, we will be back in here after lunch. Trevor and I talking about another open source project in Linux Foundation called Paladin, which has to do with privacy solution on top of EVM and building pluggable privacy. So just another piece of the whole ecosystem. So we'll be back here if you want to